So today, guys, we're going to discuss the combined gas law, which is used to predict effects on the properties of gases when you're changing factors. So for instance, if you're given a set of initial conditions, initial pressure and temperature or volume or moles, and you're asked to changing a couple of those and asked to find a new volume, pressure, temperature, or moles. So it's P1 V1 over N1 T1 equals P2 V2 over N2 T2, where P is pressure, V is volume, N is moles, and T is temperature Kelvin. Has to be temperature Kelvin. And the ones are your initial or starting conditions, and your twos are your final or ending conditions. I like to teach it like this because this actually has all of the gas laws in it. So this is the only one you have to really use if you understand it in a certain way. And we'll talk about why as well next class. But when a variable is not mentioned, we assume it to be constant and we remove it from the equation. Okay. So for instance, if moles are constant, we remove N from the equation. So I'll talk about that in a moment. So first off, so all the gas laws are here. So if you're at constant moles and temperature, moles is N and T is temperature. So I just cover up my moles and temperature, and I'm left with Boyle's law, which is a gas law, talking about changes in pressure and volume and the effects of them. So P1 V1 equals P2 V2. At constant pressure and moles, P is pressure and N is moles. I cross those out, and I have V1 over T1 equals V2 over T2. This is known as Charles' law. Constant volume in moles, I cross out moles, N, and I've crossed out my volume, V. And I have left P1 over T1 equals P2 over T2. And this is Gay-Lussac's law. And at constant moles only, you guys will find the normal form of the combined gas law. So this is the normal thing you see in the combined gas law. But one thing that is important to understand is you need to be in temperature Kelvin. In order to do this, all you have to do is take the Celsius temperature and add 273 to it. And then you will convert to Kelvin. We've talked about that last unit, so we were pretty good at that. So let's keep on going. And one more thing, standard temperature pressure. Standard temperature is 273 Kelvin, which is 0 degrees Celsius. And 1 atmosphere of pressure, which is 101.3 kilopascals, which is 760 millimeters of mercury. So let's go over an example problem. A sample of gas is occupies 200.0 milliliters at 150 Kelvin at 1.5 atmospheres. What is the pressure if the volume is decreased to 100 milliliters and the temperature is increased to 300 Kelvin? So the way I like to go about these problems is I start out by making a little table or chart of all of the variables and figure out what we're given and what we need to find. So for instance, a sample of gas occupies 200 milliliters. Milliliters is a unit of volume, and you can reference your PVU tables, your pressure variable unit tables if you are confused about the units. And at 150 Kelvin, which is a temperature, at 1.5 atmospheres, that's a pressure. What is the pressure? I want to find a pressure if the volume is decreased to 100 milliliters, a second volume, and the temperature is increased to 300 Kelvin, a second temperature. So I'm talking about changing my initial conditions. I'm changing my initial volume from 200 milliliters to 100 milliliters, and I'm changing my initial temperature from 150 Kelvin to 300 Kelvin. So let's start to fill in some of these boxes here. Oops. So one thing you guys might notice is there's no mention of moles in here. So we don't have to worry about the N. We get rid of that variable. Okay. And I get my initial pressure, 1.5 atmospheres, my initial volume, 200 milliliters, my initial temperature, 150 Kelvin. My final volume, 100 milliliters, my final temperature, 300 Kelvin. And what is the new pressure? That's why I highlighted that in red, because that's what I want to know. You guys can call that any variable you want. If some people are familiar with X and that's what they want to do, that's totally fine. I'm going to leave it as P2. So I have my combined gas law here. I don't talk about moles, so I cross that out. Don't need that in the equation, and I have my normal form of the combined gas law. All I do from this point is I substitute in all the variables. My P1, 1.5, my T1, 150, and my V1, 200, my V2, 100, my T2, 300, and I want to solve for P2. Like I said, you can use any variable. Some people like to use X. Some people like to use, I don't know. I like to keep it as P. Even sometimes people keep it as question mark. Anyone's okay as long as you define your variables. So one thing that's interesting is your units will cancel out. So I'm canceling out my volume on both sides, my temperature on both sides. And what unit am I left with is atmospheres, which is a unit of pressure. So I should calculate after this. I can cross multiply, or I can solve each individual part. Either way, you should get 6 atmospheres. Okay. So I will go over a couple more of these. Okay.